Today we have a new face in our buckle up. Dennis over here.
Hello.
He has a lot of experience under his belt, and he's actually one of our team members here at Blue On.
Mike couldn't be here today because he's out working with technicians. So, in honor of Mike, and thanks for being out there and doing that, Mike.
Oh boy.
We're taking these off.
Oh, we ain't.
We ain't.
Yes.
I am. I'm going to take these off in honor of Mikey. So, I don't have sandals, and I ain't going to wear a sandal. But there you go.
Show them the socks.
Burger socks, guys. Burger socks. We want to hit on a few key topics, and obviously we want to take your questions on charging and tuning that you might have. The general pieces that we run into when you guys are doing the charging and tuning, it doesn't matter to me whether you call in and you've got analog gauges or digital gauges, but the biggest thing that you got to have is gauges and a way to read the temperature of your liquid line and your suction line, okay? If you don't have that, we can't check superheat and subcool. Superheat and subcool, and we're going to be unable to finish off what we need. So help us, help you, help you. Dennis has got, well, he's 2 years younger than me, so he's got a bazillion years in the trade. He's been around here. He's a super good dude. Dennis has got a piece for you that he wanted to talk about, so I'm going to pass it over to Dennis.
So, in taking some of the tech calls that I've been taking, and since I've been here, and some of the guys, most of you guys, this is going to be really elementary for you guys, but a lot of the guys that we have, call in, they're still in school, they're still apprentices, they're still learning. And so I thought if we're going to talk about charging, perhaps we should go all the way back to the very beginning when we start to charge a system. So if you've got your system pulled down into a good vacuum, let me just stress, being an old timer, just let me stress, a good vacuum is imperative with these blends. So when you've got your system down and you're ready to start charging, I'm speaking right now, and in my mind, I'm thinking about a split system heat pump, which is largely where we have a lot of calls on that. Several things you want to do. We want to, first of all, get your scale out so that you know how much refrigerant you're putting into this thing. The second thing you want to do, and of utmost importance that I'm thinking, is charge liquid into the liquid line. Do not charge liquid at first in a vacuum into your suction line. Most certainly don't get on the true suction. So in a heat pump, again, for the guys that are just learning, you've got the big line, the vapor line, and that's going to be your suction and cooling. Okay, don't charge into that when you're in a vacuum with liquid. Do not charge liquid into the what we call the true suction, which is that other little Schrader sticking out up there. It goes directly in and ties into the suction line right before the compressor.
Yeah.
So you want to introduce liquid into the system, into your liquid line first. What I would suggest most of the time is that you
Liquid
look at...
line's the small one.
So probably need to clarify that. The small line, when you look at your high side gauge, is where you want to, like Bryan said, it's the small line. You want to introduce your liquid you want to start charging with liquid into that port. Okay, and the reason for that is the same reason we go into suction, superheat, and go a great deal length on that is because we don't ever want to introduce liquid refrigerant into the compressor. And that's the whole idea there. So when you introduce it into the liquid port there, you've got the condenser on one end, you've got the evaporator on the other end, and you can, for lack of a better term, dump most of your charge on, depending on conditions, ambient conditions, you can get most of your charge in there. And then once you get started and you get the unit up and running, and we begin to take, like Bryan's going to talk about, temperatures and pressures, then we can begin to bleed, let me use that term, bleed liquid refrigerant into the suction line to finish trimming up our charge.
But
Yes.
I'm going to back up a minute.
Yep.
So Dennis used the term, you got it in a vacuum, 500 microns or less.
Right.
That's a good vacuum. 1,000, 1,200, 1,700, that's not a good vacuum. You need to get it down 500, below 500. That's point number one. When he's talking about breaking the vacuum and charging with the liquid into the liquid line, that is without the compressor running. So you've got it in a vacuum and you're pre-charging your line sets, you dump into the liquid side, And on a hot summer day, you got to be careful. He mentioned the scale. You want to make sure that you don't overcharge before you even start the machine. Where he's talking about the true suction is that 1/8 inch port that goes right into the suction of the compressor. If you were to open up that valve on the low side and start pumping liquid into that 1/8 inch line, that 1/8 inch line is going to feed right on top of that compressor. And when you fire it, chances are you're going to have a really angry compressor if it survives that start. So that's what he's talking about there. That was all before applying power to the machine.
Yeah, let me back up based on what you're saying. Never, ever run a compressor in a vacuum. That's just that's a hard, fast cardinal rule that it's been ever since I've gotten a trade. When we got a system in a vacuum, do not energize it.
That's our prelude to HVAC 101 on the 15th.
Okay. but
It's all good, man.
don't do that because you could very well short the compressor could short to ground. So anytime you've got it in a vacuum, be absolutely sure whatever you got to do, we do not apply power to the windings in the compressor.
Can you charge a heat pump during heating mode in winter?
No. You can add refrigerant to it, but you are not going to charge and tune in heating. Most of the machines that are out there have a chart that's going to get you within range if you did have to add in case you had a leak. But no, to properly charge the machine, it has to be in cooling. So going back to what you were saying, where I interrupted you, was the reason for using the actual suction line in cooling rather than the 1/8 inch port.
Absolutely. If you're looking at a heat pump, that vapor, that's the reason we call it a vapor line. In cooling, that's going to be your suction. And so it should be a little lower pressure than your drum pressure, and you can bleed refrigerant in. If you put it in heating and you open that up, your refrigerant's going to come out of your system and back into your drum. We don't want that. So let's be very careful. One other thing I thought that I should mention, again, going to the guys that are just starting, absolutely understand that, correct me if I'm wrong, but anything outside of R22 as a blend, you must charge in liquid form. Otherwise, you distort the blend. You distort the proportions of the blend, and we don't even want to talk about all the problems that can cause. So always charge in liquid form, particularly in a blend. Try to get as much as you can in on the liquid port. Start your unit up. Then you can start bleeding some, and again, bleed, don't dump, but bleed refrigerant into the suction line until you get it close to where you need to be. Paying attention to your scale, so that you don't overcharge the thing. And I'm a big proponent because of experience. You know, you got a leak on a system, you fix that thing, you start charging and you're dumping, you're not paying attention, and you figure out that your TXV or your orifice or something's plugged up and you done dumped a whole bunch and you're waiting on your suction to come up, and dadgummit, now I got to pull refrigerant back out and start over. So watch your scale.
But bleeding. We're not talking about cutting yourself with a knife.
Okay, good point. So when I'm talking about bleeding as opposed to dumping, so in other words, we don't just open up our valve on the suction side and just blow refrigerant into that suction line. What I mean by bleeding is we incrementally feed the refrigerant into the suction line. Forgive my terminology.
And my rule of thumb on that, rule of thumb on the bleeding or cracking the valve is 15, 20 pounds over suction max. Machine running.
Gotcha.
If my suction is 100, then I'm at 105 or 110 feeding in, not 150 feeding in.
Again, the whole idea being that we don't want to introduce liquid refrigerant in slug or solid form into the compressor. Let me back up. Slug. We talk about slug in a compressor. That means we're getting slugs, big drops of liquid refrigerant in the compressor. If we're talking about flooding it, we're talking about a solid stream. So that's what we mean when we say slugging and flooding, or at least that's what I mean.
And then on your recommendation of going to the suction line versus the true suction line.
Yes.
If you're when you're doing the initial charge, if you're putting it in the true suction line, you're putting liquid, even though it's an 1/8 inch tube, you're putting that almost straight into the compressor. Whereas it's going to be a little bit more forgiving going into the suction line outside of the condensing unit, because not only do you have the warmth of the suction line, you also have an accumulator, especially if it's a heat pump. If it's not a heat pump, it's a straight cool. You're just relying on the amount of suction line to help you evaporate that liquid.
Which line should you open first on a brand new unit, suction line or liquid line?
Oh, pick me.
Bryan? Yes? Go ahead.
Go ahead. After you've pulled your vacuum, I always open up the liquid line first.
Absolutely.
And as I get that liquid line cranked open, then I come back and break the suction and slowly open that one. I'll go pretty quick. If I've proved that I can hold a good vacuum, I'll go pretty quick on that liquid line and then open up the suction one pretty slow.
Dennis, you got a lot of good feedback. Dennis is doing really good, y'all. Dennis is fire.
Yes.
How about charging a system in AC mode and low ambient pressure and low ambient temperature with a field piece charging jacket?
Well, yeah, the charging jacket goes on the cylinder, and we have touched on this before. I'll touch on it every time you guys want to. When I'm dealing with less than 70-degree ambient, and I've got to charge a machine up, I put a blanket on the condenser, and if it, stock machines don't come with the fan cycle control. And then even when you're dealing with a machine that's got fan cycle control, it'll work to a point, and then you've got to bypass that. You got to make sure that if you're running, 60-degree outside air, which is ambient. Ambient is referring to outside air.
Right.
But I'll wrap the condenser with plastic or cardboard from the refrigerant box or something. I'll get something that I can wrap the condenser. You guys can try and put something on top of the fan, but usually you don't have something big enough to cover the fan and the air still gets through. And I just find it faster to wrap it with plastic or a drop cloth or something to slow the air up. And then I can slowly peel that back as the head pressure increases. And that's been about the best way I do it. But I don't walk off the job until my condensing temperature is correct with the ambient.
Absolutely. What Bryan said, I think it's imperative that we go back and remember the very basics, what we started with when we started this trade. All we're doing is transferring heat. That's all we're doing. And by covering up those coils on that outside condenser in cooling mode and low ambient, all you're doing is you're reducing the ability to transfer heat. So we're simulating a higher ambient temperature by driving that pressure up on the discharge side, driving our liquid side pressure to where it needs to be. So that's what you're doing. Remember, all we're doing is transferring heat in HVAC. Correct me if I'm wrong, but that's all we're doing. So I hope we're right. Anyway, all we're doing is we're simulating, and that's all a fan cycle control does, is it simulates a higher ambient temperature by cycling the fan off and on. Again, what are we doing when we cycle the fan off? We're reducing the ability to transfer heat. So that's sort of, if you will, in the back of your mind, think about that. Because every technician I know does exactly what Bryan says. We cover up part of the condenser or all of the condenser if it's really bad, so that we can try to tune that charge on a cold day. Hopefully we don't have to come back.
And you're probably going to come back when it warms up and have to tune the machine again, but that's what we do.
When y'all are talking about charging on the liquid line, is it on a dry system or a new system where refrigerant hasn't been released?
The answer to that is yes. If the machine is dry and you pull it into a vacuum, then the whole machine is dry and you're going to dump in on the liquid. If it is a new install where you piped up to the machine before you open up the service valves on that machine and release the refrigerant into the line set, you got to pull a vacuum on the line set. And once you pull the vacuum on the line set, then you open up the liquid line and let that out. And once you've let that out, you got service ports open. Then what you're going to be doing is starting up the machine. And now is when you're going to add refrigerant to tune the machine to the proper superheat and subcool.
At what SCT do you set your headmaster / fan cycle?
I try and set mine between a 75 and 80 degree day. How does that work? So fan cycle control and headmaster, the headmaster is a specific carrier part. Fan cycle control can be Johnson, it can be Penn. It's just a snap action switch that works off of pressure. So go back to your PT charts, because I can't tell you one specific pressure for all refrigerants because it's not. So look at your PT chart for a 75 to 80 degree day And that's what you're going to set that control for pressure-wise, whether it's 410, 22, 458A.
Right.
You're going to just set it for a 75 to 80 degree day. And that way you've got the cushion to keep you, it just helps to keep the evaporator from icing up. I said helps. It's not going to stop it.
By keeping enough refrigerant, discharge pressure and liquid pressure into the evaporator high enough so that we don't starve the evaporator, and that's when we start freezing up. So you and I talked about this the other day, and I think it'd be good to clarify. So when you say a 75 to 80 degree day, you and I talked about the other day in the old days, you take whatever your saturation is and you add 30 degrees to it, and that's where, take your ambient temperature and add 30 degrees to it, and that's what our saturation would be. So when you say 75 to 80 degrees,
Well, that's used to could.
Right. And so that's what I wanted to clarify. And some of the more efficient units now, that's not the case. So you clarify when you say 75 to 80 degrees.
Yeah, and guys, feel free to call us, and we'll start getting into
Absolutely.
deeper math.
Through the app. Through
Through the app, yeah. Not too many people have my phone number, nor do they want it. If you've got a 10 SEER machine, that was always plus 30 on the condenser. 80 degree day would be 80 degrees plus 30, and look straight across, and that would give you 250 pound head pressure with your offset of 35. So it would come down to about 215, shut off, run back up to 250, start the fan, or you could crank it up a little higher. But it's that kind of thing. If you're running a 14 or a 16 SEER machine and you're trying to simulate a 80 degree day, then it's probably a plus 15 degrees over ambient. So if it was 80 degrees outside and you're doing 15 at 95 degrees, look at 95 degrees straight across on your PT chart, and whatever that pressure is what you're trying to maintain.
Exactly.
Is that what I was talking about?
Yeah.
Because I know we kicked a lot of dirt the other day.
Yeah. So I was talking about for some of the younger guys, that's what he's talking about when he means a 75 degree 80 day. And unfortunately now we don't do the ambient plus 30 degrees. It depends on your SEER, but at least it gives you some idea as to where you want to go and where you want to get your discharge, your liquid pressure up to, so that we don't starve the evaporator.
That's good.
And HVAC 101, another one of those that I'm going to give away. I've always used a rule of thumb, and that rule of thumb has always worked. No matter what the SEER rating is on the machines, which means that they're putting bigger condensers on the machines, the evaporators are always the same size. So this little rule of thumb has worked since I got into this trade, which was a while ago. Return air, that is the ambient space inside the building. Return air, minus 40 straight across on your gauge, that's your suction pressure.
Have you guys personally experienced refrigerant dilution due to a leaky system that has been topped off multiple times?
Pick him.
I have said
Okay.
this since blends came out, and I contend that I'm right over and over and over again. If you go out to a system and you know it's had leaks, it's got some age on, whatever the case may be, I am in absolute agreement with you. And so if you're getting everything going and you're doing the proper things, that is checking your subcooling, your superheat, you know you got clean coils, you know you got good airflow, everything else is working, but none of your numbers are jiving, snatch the charge, evacuate, and introduce brand new refrigerant into that system. That should clean it up. In fact, with the blends, and the more I'm learning about blends, I might suggest you go ahead and replace the liquid line dryer just to be 100% sure that we've got virgin refrigerant in the system. So yes, that is something you will see.
For us older guys, that's the only thing we got to look for. Virgin refrigerant.
I'm back with Griffin. No, anyway, but seriously, on that thing right there, it's real important, and that's what I was talking about earlier. In charging a blend, make sure you're charging with liquid, because if you charge off the top, you're distorting your percentage of blend in that drum. What do you call it? Fractionating, and so then that drum's not going to be worth a flip from now on, and you're going to be battling that. So, absolutely, I agree with you 100%.
But I like his word dilution.
Absolutely,
that's a whole lot easier to say than fractionization.
Okay, you're absolutely
but
spot on.
But that is exactly what fractionation is the fact that you've lost more than one of the constituents out of the blend. And what is a blend? It is not a single constituent. It's not a single refrigerant. It is multiple refrigerants put together to make one refrigerant.
R22 was very, very forgiving. I talked to a guy yesterday on tech support call, and I reminded him of that. The blends are not as forgiving. And so we got to slow down enough to really make sure we tune the charge properly.
Yeah.
And to go back to your comment or your question, you're absolutely right. And that's the reason I say if you're doing everything right, you know the system's running right, and your numbers are not jiving, that is your superheat, subcool, none of that's working, your delta T's are not working out, it's time to snatch the charge, get it down to a deep vacuum. I would probably change the core.
I love having him here.
The dryer.
What he said was recover the refrigerant into an approved cylinder.
That's what I mean.
That's what
Snatch
that out.
I didn't say blow it. I said snatch it. You know. When I was young, we blew it. Nowadays, you got to snatch it. You got to recover it.
You guys are awesome. We appreciate all the attention and feedback. Peace, guys.
Say bye to Dennis.
See ya.